All right, guys, so today's project will be a quick one. We've just got to drill some holes. Drilling some holes is probably a little oversimplified, but let me show you what we got right here. All right, this is the drawing for a lens. You can see over here, there's a series of lenses. This is a collimator. And its diameter is 14 millimeters, and the tolerance is +0 minus 0.02. So inside this little purchased guy right here with fancy threads on the edge that are really hard to duplicate and I don't have a tap for, etc. Inside of this guy we want a 14 millimeter hole. So I can't grab the outside, not enough material to toe clamp it and still get the 14 in there. So luckily he had a Thor Labs threaded tube with a stop on the edge here, if you can see that. So what we'll do is thread this guy in here. We'll stick this in a chuck, we'll indicate in for center, and then lock this guy down with some of these. Yep. Good old snap-on tools. And once he's locked down pretty good, I'm gonna use a small end mill so I don't put a lot of torque on it and try to spin this thing back out. And I'm just going to come in and cut each one of these. I have a bag of these things to do, so I think this is the best solution in the CNC. And I've got a 551 gauge pin that I can do some checks with. Yeah, our goal is, like I said, 14 mil on the nose to get this as tight as we can possibly get it. So we'll see how well we do. All right, so sweeping in this guy. Now keep in mind this is 1/10 per tick. Pretty dang close. One-tenth per tick. So you can see the last thing I cut was actually in the vise, in that chuck rather. And X pretty dang close. Y a little further off. It wasn't nearly as fussy. This one's right on, as you can see. So we got our G-code in there. We're just going to turn these two to 0. Just press the go button. There we go. Alrighty, I've just gone and touched this off. This is a 3/16 end mill. We're going to use that one. It's got I think five loops. Anyways, we're going to use that guy. Touch him off on top, and now what we're going to do is set Z at 0. See that? Again, just hit the go button. Boom. All right, ready to program. Okay, these little covers are about 0.24 of an inch. So I'm just going to run 1/4 inch deep, clean everything up. Sometimes your program, all it needs is a circle. So I drew a 14 millimeter circle, and we're basing everything off that, calling out the right depths. We already indicated 0 up here at this point. So yeah, it's really just a ramp in, leaving 5 thou material, and then 3 cleanups, a thou per pass, and we'll see where we're at. Always scary. It's going to leave that that little plug in the center to fall out. So we'll see what happens, but it's pretty small. Should handle it just fine. And then we come in and do our nice cleanups. All right, so we'll go ahead and call up our G code. All right, so you can see the first little bit, this ramp in, these are all XYZ, 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 right? So essentially, this entire ramp is just going to be a bunch of straight cuts, be somewhat tessellated. Now that's reduced by my arc filtering and tolerance selections, but when you get to the bottom of the program, this is where we're actually calling up a radius to cut. And it's divided into quadrants, so that's why we have so much code here to just cut a simple circle. But there you go. That's the difference. Apologize, I'm sort of one-handed, and this is kind of difficult to show with one hand. Forgot my camera stand. Anyways, right on according to the calipers, but you know how accurate that really is. Okay, so what'll really tell the deal is right there. We've got a gauge pin. Got to go in very straight. Perfect. Might be able to tighten it up just a hair. You can see how well that fits. It's a pretty clean gauge pin. So it's slip on a 14 just barely. And there must be a burr on this side because it doesn't want to come off. So that's good. That's a very clean gauge pin. So I might take maybe 1/10 out of this, maybe 2/10 out of it, and just see on the next one. All right, so I think to leave a little material just on this second cleanup pass right here, this spring pass, we're just going to leave 001. Try that. All right, I didn't want to run the first one on camera. I wasn't sure what was going to happen with that little piece that detaches on the inside. So here's the second one. We've made the adjustment and brought a new program in. Halfway. All the way. Now we do our true contours. 1 thou per pass, 3 passes. right, so if you remember, we made a 1/10 adjustment. That's 1/10 per side, so the hole got 2/10 smaller. Same exact gauge pin. No matter what I do, that thing does not want to go in there. Starts a little bit, it's really close, but it's tight. So that tells us that that hole was pretty dang close before. So we're going to take half of what we did out and try to cut it again and see if we can just get this guy to snug in there. Alright, this is the second pass. We should see just a dusting of chips on this third pass. There we go, there we go, there we go, there we go. Alright, this is where we're at. Fourth attempt. 4 adjustments, and you know, these guys are going to be usable, but I just wanted to get this dialed in to provide most of them with the closest accuracy I could possibly get. So it takes 2 hands to get this guy on there. It's got to be absolutely perfect, and that pin does not fall out, yet it does slide. It's a nice tight fit. Getting it off of there is also a challenge. Got to be straight to come off of there. So there we go. And the number we arrived at is a little more than half of a tenth. So now we just got to burn through the rest of the bag and get these guys done. And there we go. I got them all done. Each one of them was fit. Made sure that each one went over this this gauge pin, and they are snug, but they go right. So that means they're over 14 millimeters. Something very close to that. So anyway, that's an interesting way to achieve a tolerance that is something beyond what I can measure. Actually, I have ways to measure bores that get pretty accurate, but not this small. So yeah, I know there are all kinds of tools, and you know, I've got gauge pins that go up to 3/4 of an inch, and from that point, my other tools take over. So this is kind of how we do it here. It's by feel, you know. This is something you can't teach. By feel. So that's why I think that's why I think that machining, there's a bit of an art to this, you know. This is something you don't learn in a book. Anyways, earning my keep today. Simple project, in and out. This only took about an hour. Good engineer, knew exactly what he wanted. He gave me the drawing, said 14 millimeter minimum, but I want it tight. And I know that the lenses, as we showed in the drawing, the lenses will come in 0.02 millimeters under max. So it's either going to be a really tight fit or a really nice tight fit. So anyways, that's exactly what he wanted. He ordered more than what was necessary, something like 12 of these we did. That allowed me to kind of hone in on what we wanted. 2 of them were a little looser than the rest, but I'm sure still well within tolerance. So yeah, there we go. A day in the life of a telescope machinist. So there you go. Anyway, like, share, subscribe, stay tuned. More videos coming.